Enzymes. Remember, proteins perform a variety of functions in the cell. There's a special group of proteins called enzymes. Enzymes are incredible proteins, with a highly specific. Their role in the cells, as well as in the body, is to take certain substrates, or other molecules, bind to them, and then do some sort of thing to them, either breaking down, putting together, or catalyzing reactions so that they go faster. What is an enzyme? An enzyme is a type of protein, always ends in ase. Enzymes are a special group of proteins that are highly specific, meaning they won't bond with anything else. Most often they end with ase, such as catalase, amylase, and RNA polymerase. Your cell and body use enzymes three ways: to break things down, to put things together, and to catalyze reactions. Enzymes' roles can be fallen into these three categories, whether it's taking two monomers and forming them together to make a complex polymer, taking a complex polymer and then breaking it down into its individual monomers, catalyzing/lowering the energy of a reaction. We'll see this aspect later and explain it further. Parts of enzyme. Enzyme consists of three key parts. The enzyme consists of an enzyme, an active site, which is an area in the enzyme, and a substrate. Active site. This is the site where the substrate will be affected by the enzyme. Substrate. This is the molecule the enzyme is going to affect. Enzyme. This is the actual protein that does the work. All enzymes follow this specific pattern of taking a substrate and bringing it into the active site and then affecting it somehow. The idea of how specific enzymes are is known as the lock and key mechanism, where individual keys fit only one type of lock. The same thing works for enzymes, where only one type of enzyme will fit with one type of substrate or molecule that it's going to affect. This makes sure that you have highly specific enzymes doing the exact task they were asked to perform, so there's no confusion. How enzymes work. Putting things together. Enzymes will take substrate monomers and put them together. One example of this is RNA polymerase, where it's taking the monomers of the RNA nucleotides and putting them together to create long chains of RNA. Notice, RNA polymerase ends with the ASE, making it an enzyme. Breaking things down. Enzymes will take large substrate polymers and break them into monomers. Sometimes molecules are very large, and to help speed up, enzymes are used. An example of this is amylase, which takes the large complex molecule as starch and breaks it down into individual glucose units. Once again, ACE indicating an enzyme. Catalyze reactions. All reactions require an amount of energy to go. Activation energy is the amount of energy required for any reaction to go. Think of it this way: a person wants to roll a boulder over the hill, but it requires an amount of energy and work to be able to push the boulder over the top of the hill, where then it will roll on its own. This is the same as chemical reactions, where the reactants want to go and create new products, but they need a certain amount of energy to get over. Think of it this way: I have a piece of paper here. This piece of paper is held together by molecular atoms, and they want to fall apart, but they won't. The reason why is the amount of energy needed for this paper to be able to fall apart and turn into carbon is really, really high. How high, you ask? Well, that's simple. It's about as much as a flame. Once lit, I've put in enough energy for the reaction to be able to go. Now it can go to completion. Fire burning is a great example. On its own, fire won't burn at all, but when applied with a little bit of flame, it'll start to take off. That's because the amount of activation energy needed for it to go has been met, and now the reaction can go to completion. This also explains why diamond and charcoal are different. Diamond is pure carbon, and it naturally wants to fall apart. However, the amount of activation energy for it is an incredible amount. If you were to put enough energy, however, you would see that diamond turn into charcoal and be worthless. Don't worry, ladies, the amount of energy needed to make a diamond turn into charcoal is really high. A catalyst is something that lowers the energy for a reaction to make it go faster. A catalyst makes it so the hill isn't as steep anymore. Now it's just a simple hill for it to go, thus making the reaction go much, much faster. Here how it looks. This is a chart of a normal reaction, where the amount of energy needed to go over and go to completion is really high. I know the idea of a catalyst can be kind of confusing. Just kind of recognize the chart and you'll see more of them in chemistry. Just remember, a catalyst makes a reaction go faster. If anything, walk away with that. Think about this too if you wanted to as well. I'll leave you with this question. Why might a mutation then, that does randomly cause something bad, might be fairly harmful, and especially in terms of an enzyme? Look forward to seeing you guys tomorrow.